hills would you rather climb? Take a second, look at both, think about which one you would rather and why. Which one would we rather climb? Maddie?
The second one.
This one?
Yeah.
Why?
It's not a gradual incline instead of like a straight up incline like the first one.
Okay, so you're saying it's not. Okay. If you didn't catch that, she said it's more of a gradual incline, like maybe slowly over time. There's more of a hill, and this it is a hill the whole way through.
Well, I think it would depend on what I would get if I climbed either one. Like if like A was going to like the top of the mountain and had like a beautiful view, I would do that one.
Okay.
And if that one was just like, so that one had like, you know, like I think the reward.
Okay. At the end.
Yeah.
What are we getting at the end? Okay, that would depend. Okay.
The first one's so crowded.
What if it wasn't? What if there was only that one person on it?
Yes.
Okay. Why?
Because it just looks better.
Looks better
Wait,
in what way?
It's not straight up.
Okay. It's more aesthetically pleasing
And the view.
for exercise, I guess. Anyone else? Okay. I would probably also do this one, but I also just don't like extraneous exercise like this anyway. But probably like Maddie, what you said, I could probably get up this faster than I could get up this, and I'd be more winded if I tried to climb this. But be thinking of those type of descriptions when we go into some of the stuff we're going to do today. All right. So we're now. Before I do that, sorry. Back. So new course calendar. We have now started Unit 2. So Unit 1. Remember, we didn't really have a test. You guys had some formatives, and that was about it. We're going to revisit that unit, scatter plots, and all of that stuff throughout. You'll see some of that in this one as well. You'll see that these days are kind of packed. Now, right now it's intentional to see how much we can get through, because this is new for me also. They changed the standard, so this is kind of a trial. See if we can get through this stuff. If we need to push stuff, we'll do that. These are always tentative. So, on there you'll also see all of your delta maths. One is a Desmos. Some are formative, some are informative. So do them all because they're all great practice. But be mindful of which ones affect your grade and which ones do not. The quiz is tentative at this point, depending on if we get to it or not. It would be like just a review quiz. So we're either going to do study guide review type thing, or we're going to do a review quiz. Haven't gotten that far yet. We'll figure that out the closer we get, but there will be a test. So you'll have some sort of review on that, but we'll talk more about that when we get there. Questions about the course calendar? Okay, so hold on to that. I have not posted that in Canvas yet. My goal is to do that today. All right, now, as we're going through this unit, a lot of what we're going to do, you'll see this same standard because a lot of it falls under it because we have to talk about the different pieces, but also all together. So we're going to start with slope, which is something you should have covered last year. Maybe not to the extent that we're going to do it, but some of this should be familiar. So things that should be familiar, or maybe you've heard it before, we use the letter M to represent slope. So anytime you see M, be thinking about slope. M represents the change in Y over the change in X. Or you may hear the vertical change over the horizontal change, or rise over. Does anyone know this? It's also known as the constant length of length. It's another way of saying slope. It's okay if you don't. So another way you might Here slope being described as a constant rate of change. Between points on a line. Because whatever that rise, whatever that vertical change is from one point to the next is the same, and then the horizontal change is the same from point to point. So we're going to first find the slope of the points by using this, looking for the vertical change and then the horizontal change. It does not matter which direction you go vertically first. So if you go up first, that's fine. If you want to go down first, that's fine. Meaning it doesn't matter which point you start at. So let's say I'm starting at this point. I would count how many units up. I'm just going to do this for visualization. Let us see. 1, 2, 3, 4, 5, 6. You don't have to do that if you can see it. And then I'm going to count how far over. 6. So that vertical change went up 6. That horizontal change went to the right 6. Just so you see that a little bit better. So that would be some 6 over 6, which would simplify to what? 1. So the slope here is really just 1. That means every time I go up 1, backtracking, all whole numbers are really fractions. This is really 1 over 1. The 1 in the denominator is invisible. So every time I go up 1 and over 1, there should be another point on that line. And I could follow that all the way through and keep going. And that would show me that constant rate of change is always doing this. Right. Who remembers anything about slope? Does this look familiar? Yes. Okay, good. Right? So this was a positive slope. There are 2 ways to get a positive slope. By going up and right, or you do the opposite. By going down and left, and I'm going to show you how. So let's say instead of starting at that bottom point, you start at the top. And I count it down 6. And then to the left 6. Down and left are both negative directions in general. But if I have a negative over a negative, they're both going to cancel out and just become positive. So both of these would still be positive no matter how you did that. Questions on that? So then we're going to count this slope. I want you to see if you can count that slope. Go ahead and do that. So again, it doesn't matter which point you start at, but you're going to go up or down first, and then left or and then left or right. What did we get for that slope? -1/2. So that would be the simplified answer. If you were counting from point to point, we're going down 3. And over 1, 2, 3, 4, 5, 6, which was simplified to that -1/2. Now, when you do your negative, it has to go in the numerator. It doesn't matter if you were thinking, well, I went left 6 and up. I went up 3 and left 6. Still put the negative either out front of the whole fraction or in the numerator. Visualization, just so you have the other directions that negative can go, down and right or up and left. Do the same thing for number 3, find that slope. What do we get? 7 over 2 was correct. Anyone not get 7 over 2? So all of your slopes should be in some either fraction format, and really, I should have wrote this like this. I just kind of ran out of space. Either in fraction format or it'll be a whole number. If it can be a whole number, make it a whole number. Okay. What are the y values of the coordinates? 4 and -3. I'm going to write it in order. -3 and then 4. What about, what do the y values represent? We're going to talk, you keep that word in mind. Kind of. The what? The rise. Or what was another word from the top of that it might describe? Or words. So that would be both the x and the y. It's part of that. The vertical change. So we need to be thinking that when we talk about the y's, that it's the rise, that it's the vertical change, so we don't confuse that. Right? If you already know how to find the slope algebraically, then this will kind of be redundant, but that's okay. If we were trying to find the slope algebraically and you didn't know how could we find that from the graphs? How could we use those y values to get a part of the slope? If we're trying to look at the vertical change, look at that rise, how could we determine that? Ryan? Yeah. If we subtract it, but subtract it how? Like, could I just do -3 minus 4? Does it have to be in a specific order? Right. Okay. Okay. If that thought comes back, you can say it. If I subtracted 4 minus 3, 4 minus a -3, would I get the same thing as if I subtracted -3 minus 4? No. So there has to be an order. So we just got to figure out which order is right. If I'm looking at the vertical change, that's usually whatever it started with to whatever it ended with. But how could I show that in subtraction? Think about that. We know we're subtracting. The how exactly we'll figure out here shortly. What about the x values? What are the x values of the coordinates? Okay, 5 and 3, 3 and 5, yes. And what do those represent? So think about our answer for y. The horizontal change, and what else? Someone said something, but I didn't catch it. Okay, yes, that is true. Related to what we put for the y values here, what would it be?
Oh, the run.
The run. Same thing. We're going to be subtracting, but we want to think about how we could subtract those two values to kind of get the slope. Anyone think they have an idea of how to do so yet? This one might be a little bit easier. I'm thinking about the horizontal change from start to end. If I wanted to measure a distance, let's say I started here and I wanted to walk to the door and I wanted to know how far I walked, would I subtract my end? Would I do end minus start, or would I do start minus end? Which one would make more sense?
Start minus
So if I'm starting, let's say I'm starting here, this is at 0 feet. Let's say that's 10 feet. I want to do 0 minus 10? No. So I want to do n minus the start. And that's going to be the same thing for the y values. Questions so far about how to find slope on a graph, what the x and y values represent and mean. Okay. The next page is a lot of practice problems for you to do later. I don't think there's any on there. Well, we're going to come back to some of them also. Okay. So these will be practice problems for you to do later. Skip that page and go on to this one. So, find number 4. I meant to label these as page 1, 2, and 3, and I forgot. So we kind of came up with like a rule for the y's and a rule for the x's. We know we're subtracting that n from the start. We know the slope in general is that vertical change over the horizontal change or the rise of the run. How could I put all of that together to come up with one equation? Now, the actual equation is given, so if you're looking at that, maybe think about how could we put what we wrote in words and match that. Any ideas on that? I'll give you a hint. We need some sort of fraction. So let's dive into that more. We know already that it's going to be rise over run, but we want to take what we just talked about, that we're subtracting the end from the start, or the start from the end minus start, in both the y's and the x's. How could I write that here? So, which values are going in the numerator? Y's. And if we're starting with the end, that would be like our y value end minus our y value start. Something like that. If we're finding like a general rule. So then what would the denominator be? Minus the x start. So if we kind of think about it like that, that will help us kind of understand the formula that's given. So if we were to test that out here, we are given 2 points. I'll rewrite them just in case it's hard to see. I think that's a 5. So if we were to do our rise over run, what number is our y end? 3, okay. And then our y start? -3. And I'm going to write it like this. What is our x end, our x value end number? -2 minus our x value start number, -5. You can do this by hand. I'm also going to show you just really quickly how to put negatives in a calculator. So in your calculator, which I don't have open. Oh, but I could do it from here. My board and stuff is just switched, so I'm like trying to get that in my mind. Okay. If I did 3 minus, so these are just like normal, but to get your negative, that's the one down here. So it'll look a little smaller, a little higher. When you have a minus and a negative together, you're really adding. That the two negatives come together, they make a plus. So if you wanted to also rewrite it, you could do that. Because that means the same thing is going to happen here. What should that slope be? Go ahead, Sanjay. 6 over, what was the last part?
16. I got 16.
Okay, as the final answer. What is that? Double check that. Because we're starting at -2 and going up 5. Say again.
6 over 3.
Thank you. Sorry, I just can't hear. Which would reduce to -2. So it should be a +2 for a couple of reasons. Because one, on the graph, I see that this is going up and to the right. So it would still be positive. And all of these were also positive. Now we're going to double check that on the graph. If I go up 2 and over 1, I should end up at another point on this line. And that happens to be the case. So our general rule worked to do this algebraically, just as if we were finding slope from a graph. Now you're going to have a chance to explore that more. So yes, you were correct. At the bottom of that page, now we're going to do the same thing, but now we don't have the graph. Now we're going to use the rule. So really quickly, this is the same thing. The y2s, the y1s, it's just labeling them. So you can still think about the y2 as the end, the x2 as the end, and the y1 and x1 as the beginning. But also, if you switch one of them by accident, it doesn't really matter. Let's say I switch these two because I forgot the order. As long as you also switch the bottom two, you're good. But if you only switch one, you're going to end up with a negative when you should have had a positive, or vice versa. So just be mindful of that. So let's use that formula to do this. But really quickly, pick a number, whatever number you want, your favorite number, divide it by 0 in the calculator. What happens?
Error.
You get an error. So we cannot divide by 0. You get an error. And we'll talk about what exactly that means here in a moment. So using our formula, if you would like to label, if you're a visual person, I'm a visual person, so I like to see things. If you want to label which ones are which, you could do that. Let's say I'm calling this first order pair x1, y1. Word try, okay. And then the second one, x2, y2. Then I could take that and put it into my formula. I kind of ran out of space right there. But m equals my y2, my end, 8, minus my y1, my start, 7, over, starting with x2, my end, -4, minus, you're always subtracting no matter what, then you're -2. Once you get the hang of it, if you would like to change that to a plus, you can. but don't just make negatives pluses. That's where it gets confusing. Once you have that, I want you to go ahead and calculate that. What did we get there? 1 over -2. So actually, yes, that's how you would write it at first, but then when you write your final answer, you want that negative either out front or in the top, in the numerator. Never actually in the denominator. Don't write it like that. You will never see it like that. Questions on anything for that problem? Has anyone done slope formula before? Okay. I was going to say, maybe a few of us, most middle schools don't, but some do, so. Alright. We're going to do number 8. If the labeling helps, keep doing it. If you can see it and do it without that, you don't need to do that. So I'm going to go ahead and label again, x1, y1, x2, y2. And then put that into my format, 15 minus 5 over 6 minus 4. And figure out what that slope is. What do we get for that slope? 5. Should have 5. So for me, you're going to be showing a lot of work, so I want you to show me that you got 10, that you got 2, and then that you simplified that to 5. There's a lot of things that I don't assume how you got this. I question, how did you get this? Even if I actually know the answer. So show me everything as if I don't know anything of what you're doing. Okay? Zach, what was your question? You didn't have a question. You were raising it. Okay. Got it. Alright, go ahead and plot these points. So plot x and then y. Go. So I know slope is rise over run, but plot x and then y. I know we did that on our scatter plots. -4 and 5. Now, we're going to do the slope with the slope formula, find it, and then talk about this last part. You can probably kind of see it right now, but let's do it also. So we have 5 minus 5 over 3 minus a -4. What would that slope be? Tyler, is that sun bothering you? Okay. What do we get for the slope?
7.
For the denominator, sure. What about the numerator?
0.
It is 0. What does 0 divided by 7?
12.
0. So not technically nothing, but it has a slope. The slope is 0. And this line would look something like this. That was supposed to be straight. It was not. So when you have a straight line that looks like this, you have a 0 slope. Is this a horizontal or vertical line? Horizontal. So when you have a horizontal line that looks like this, you will have a 0 slope. Somewhere on the side, right like this. H-O-Y. This is just a way to remember this because we're going to use it a lot. This just means horizontal lines have a 0 slope. And this part will come in handy when we get to graphing, but is a y equals. So horizontal lines have 0 slope and are y equals. And go ahead and turn that over to the back. Go ahead and plot the points. It kind of already tells you what the slope is, but I will still set it up. So in this problem, so remember last problem we got 0 in our numerator, it was 0, correct. In this problem we get 0 in the denominator, which we found out earlier gives us an error. When we get an error, that is undefined, or you can put U and V. That is an undefined slope. And that line would look something like this. Is this a vertical or horizontal line? Vertical. And then write this. No. Kind of similar to the HOY. Vertical lines have undefined slope and are x equals. So 11 and 12 we kind of already touched on. I forgot that those were questions. But what can you conclude about the slope of all horizontal lines? They will always be 0. M equals 0 for all of them. You can write that. And then the slope of all vertical lines is undefined. That was supposed to be an M. Alright, I'm going to take a quick break from just talking. Pick one of 13, 14, 15, or 16. Do that in like the next minute or two. And then if you have any questions on any, we'll check them and then we'll move on to the next page. Make sure you're always simplifying. If you get a fraction at the end, either reduce it in your mind or I'll show you another trick that the calculator can do. If you press these buttons, alpha, the green button, y equals, and then 1 or enter, you'll get a fraction bar. If you put in said fraction, let's say I put in, making up 1, 2, 8, it will simplify it for you. So you can use that. If you get anything with a 0, make sure you're simplifying it to the correct thing, either 0 or undefined. Again, there's another practice page for more slope from the equation, but go to this page. This will probably be the most notes in the unit just because there's a lot of slope stuff we gotta cover. given this table, and we want to figure out what do we notice about the slope and y-intercept from the equations. What parts stick out? How did we know this was the slope? How did we know this was the y-intercept? Or where can we find that in the equation? What do we notice? Any of those things? Where is this in the equation? Where?
Like before the x.
Okay. Does that happen for all of these?
Yeah.
Yeah. So all of the slopes are found before the x, and then the y-intercepts are the last number. So kind of that. You can write that if you want. Slopes are in front of x. Y-intercept is last. And you may know this format already. Again, remember a lot of this could be review. So then if that should be the case always, what's the slope of this equation? Based on what we found in the table. 2. And then the y-intercept? 3. So we need to know how to find those pieces from the equations given. This is going to be a little bit different, something different. So we have some, I think it was Laura that said something about this earlier, independent variables. These are going to represent your inputs, your x values. So we have some inputs. We're going to input these into our x value for this equation. So we can do that by using parentheses. We kind of want to get away from the dots unless we need it, and then the x's. We use parentheses. Put those numbers in. And then we're going to figure out what the output is. So if I were to multiply 2 and negative 3, I'd get what? Negative 6. And negative 6 plus 3 is negative 3. So that means my ordered pair would be my x value and that y value, negative 3, negative 3. And once you get that point, you're going to plot it on the graph. Okay? You can do the rest with me, or if you think you got it, you can go ahead and fill in the rest of the table. So I'm going to keep doing this. I'm going to go ahead and fill out all of this next line, because it's going to be the same, except I'm just changing what's inside the parentheses. And then I'm going to multiply those first pieces. So we have negative 4 plus 3, 2 plus 3, 0 plus 3, 2 plus 3. Oh, that should have been negative 2. And then 4 plus 3. Which gives us negative 1, 1, 3, 5, 7. And then I'm going to plot all of those points. And if those in the back can't see, or if it's hard to see, I can zoom in. Just let me know. Negative 2, negative 1, negative 1, 1, 0, 3, 1, 5, 2, 7. So sometimes you'll have to make up your own data to graph the lines. And then in this, we are going to kind of introduce the definition of y-intercept. So y-intercept is where it crosses the y-axis. So on the y-axis, what point crosses that? Close. Double check that out. So on this, what point crosses that? That was a little tricky. 3. So this point right here would be our y-intercept. But I'm just going to label that as 3. And then we found the slope kind of already from before, but now we want to find it from the graph. If we were counting that slope, what would it be? 2 over 1 in a fraction, but just 2, yes, okay. And then, how do we know if these points actually fall in the line? So let's say maybe we were putting in the input and maybe we calculated it wrong. How do we know that this is actually, these are actually the points, this is actually the slope? If we were to, let's see, choose one of these and put it back into our equation, so choose 3. Which 3 do we want to use? Which 3 points? The first 3? Okay. So I'm going to use our equation that y equals 2x plus 3. I forgot, I can't extend this, so I'm going to have to add a new page. And I'm going to use those first 3 points, so starting with -3, -3. I know this is my input, this is my output, which means this is my x and this is my y. If I put those in for my x and y, I should get it to equal a true statement. So if I put in those x and y values, exactly where it is, and I figure out what this is, they should give me the same thing on both sides. I know this is -6. I know this becomes -3. This is a true statement. It equals the same thing on both sides. So I know this is, in fact, a point that falls on that line. I didn't make any mistakes. Okay. Really quickly, I'm going to do the other 2, just so you see that those also work. And you could do these for all the points, but that would take a lot of time. -2, -1, and -1. Sometimes the board likes to just change colors randomly. I can't do that. So if I were to check these really quickly, we have 1 equals -4 plus 3. That does equal, sorry, I think that was -1. It was, okay. And then the other one, this does equal 1, so it is. So double checking yourself like this is a great way to figure out, did I graph this right? Did I find the slope right? All of the things. Questions on this? The back should go kind of fast. And then you can explore. Alright, so one important piece of information that you need to take away from what we just did, each point on the graph in the linear equation is a solution. That's why it was able to work in that format, that true equation, because it is a solution. We'll come back to that word again. This is your slope-intercept form, where you are given your slope and then your y-intercept. You will use that a lot. We know the M from previous stands for what? The slope. So then the B and this is your y-intercept. And that's how also we were able to see from the table which one was the slope and which one was the y-intercept. So in part A, the slope here is what? -2, the y-intercept. 1 for the next one, the slope is -7/6, the y-intercept. 3/4. The slope in part C, 5, the y-intercept. 0. So if you don't see a number, assume it to be 0. And that's also going to come in handy for what we're about to do. Right? This is kind of just the opposite. How would I write this in the slope-intercept form? So it's always going to start off y equals what signs? -2/3 x minus 4. B is going to be written very similar to how we wrote C, and then the very last one. Okay? So now, I think this is a group thing. Oh no. Okay, you guys are going to be in groups for everyone at your table. So you will each be able to play with this on your iPads, but everyone is just writing once on one piece of paper. On Canvas, everyone open your iPads. In my class, on the home page. So if you went into modules, go back to the very home page and just scroll down to Unit 2. I don't know if your iPads are locked or not because my iPad just did something weird. So if you try to go into this next link and it doesn't work, I may have to restart my iPad. So on the home page, go into Unit 2. Whenever. It's thinking about it. Okay. In lesson 1B, you're going to go into the transformation notes page. So lesson 1B, transformation notes. And on this page, scroll a little bit until you see the Desmos expiration. Click on that link. And then your group is going to follow the directions and use that to answer the questions. See if you can grab it. If there is one, there may not be one. it's not going out. Yours is also not turning on. Sometimes they just need reset, but so if you are into the Desmos expiration, you can start. If it's not doing that, give me a second. But you guys can start.